All right. Good afternoon, everyone. Thank you all for attending our meeting today. It's a very popular topic and very interesting as well. We are very excited and very fortunate to have Allison joining us today. As we all know, the topic will be covering the 5 metrics of sustainability. So we will, without further ado, give this hours to our speaker. Go ahead, please, Allison, the hour is yours.
Sure. Hi, everyone. I'm Allison Nash. I'm a sustainability coordinator at Sasaki. Susan Green of the BSA has put into the chat a link to a Google form if you're looking for AIA credits. I'm going to go ahead and get started. To the side. All right, I'm going to attempt to go back and forth between my Google slideshow and the spreadsheet. And today, the topic is the top 5 metrics for all projects right now. I was chatting with Jeff before we started here today, and I was telling him about how when I first learned how to knit, I went immediately and tried to do the most complicated pattern I could find, and then realized later I kind of needed to go back and learn some of the basics of knitting and purling and casting on and casting off. I think that's where a lot of us are in sustainability and in architecture. We tend to go towards the complicated and interesting, and sometimes it's useful to just go back and get back to the basics to remind ourselves of what really we should be tracking. Here's a brief course description, which you've seen already, and we're going to dive into metrics about water, energy, operational carbon, lighting, and embodied carbon. And I hope that you'll come away from today's lunchtime talk to really understand what these 5 key metrics mean, and you'll gain an understanding of how to use the COAT Top 10 Super spreadsheet. I'm also going to show some examples of some other firms, how they have embedded this metric tracking into their workflow. So just to take a step back, I think we're all familiar with the AIA's climate imperative. It's on the screen here. You can, when I share the slides, you can take a deeper look at it later, but we all are aware that the AIA has really said that climate is the #1 thing that we've all got to work on, and we have a big role to play as architects, so no pressure, anyone. We've got the biggest project on the planet, literally. So I think it's also important when you have that overwhelming imperative, like we're in charge of the planet, you have to kind of take a step back and be like, well, what's motivating to me? So on my personal context is, there's a picture of my dad here, just loved anything to do with nature, was an avid hiker, you can just see the joy on his face at a snowfall, snow was magic. That knowledge of just the little amazing things of nature that can give you joy is super important to me. I also witnessed my childhood home being built in High Point, North Carolina. And then as I got older, I became really interested in a lot of, books and reading. Some of the inspirational texts are on the upper right. And I have an art background. I'm not a data nerd, but I love nature, so I'm dedicated to sustainability. So the picture on the bottom right is an image of an art piece where you can kind of be enveloped in nature by Von Bell that I saw in 2009. So all of these things mixed together make my personal context. I really love being outside, so I want to preserve it, but I'm also really interested in ideas and experience. The AIA has adopted the COAT Top 10 framework and is now calling it the AIA Framework for Design Excellence. There are 10 kind of buckets or categories we're going to dive deeper into 3 of them: water, energy, and resources. And there's a link at the bottom of the screen. Why water, energy, and resources? These are the more metric-based ones, more numerically based, and sometimes the numeric ones are a little easier to tackle first. Getting back to that knitting parallel, like learning to knit and then learning to purl. Knitting's a little easier than purling, so you kind of knit first, and maybe some of the more complicated stuff comes later. So let's dive right away into water. This is metric number 1. From the AIA's website, it has some high-level ideas and questions that are useful. Good design, it conserves and improves the quality of water as a precious resource. And the questions mainly have to do with how are you dealing with water responsibly on many scales. When do you look at water? Well, at every stage of a project delivery, but you would do different things at different times. So to begin with, in concept or schematic design, you could set a numerical target for water reduction based on a preliminary calculation. And I'm going to show you how to do that using the Code Super spreadsheet. And then when you get to design development and CDs, you want to verify that what you're speccing and your plumbing engineer is speccing is going to meet that goal. And then when those submittals come in, make sure you're buying what you specified. And then you can also take a look with the owner or the user group after the project is finished, if you have metering in your project, to actually see how it's performing. If you can only do one or a few things, again, this is right front and center on the water metric on the AIA Design Framework for Design Excellence website. Benchmark indoor water use. That's what we're going to dive into. I'm going to exit this and go to the spreadsheet now. I'm going to pause for a second and make sure everyone can, hopefully Susan can put the Google form link back in the chat again. And I would encourage, I'm going to see if I can put the link to the spreadsheet. In the chat, because I think it's useful for you all if you can. Here we go, copy. If you can, to go ahead and download your own, and then you can kind of follow along on your own screen. So it's in Excel, and I've thrown it into Google, so you can, I think you can do either. When you open the spreadsheet, it looks super overwhelming, right? There's like a whole bunch of colors, lots of fields. Luckily, it's pretty well structured. So on the, if you haven't looked at this before, on the left and in this blue color, it tells you about what you're looking at. The yellow are input cells, so you can only mess around with whatever's in the yellow. And all of the green or darker gray are calculated values. And I've highlighted here in pink kind of what has populated from what I've already taken a look at. So in order to get any data out of this, on the introduction page or the first sheet, you really need to fill out almost everything you can in yellow. What's super important is like the building area, the days of operation, and how many people, and that'll help you at least get this baseline over here. So it has automatically populated the total water use and the water use intensity. I put in from, if you go to the end, there are reference tables. There's a reference table for reference water here. So you can look up based on your project use type, roughly how many gallons per square foot per year your building on average would use, which is useful. So you can start to benchmark or, set an expectation that's kind of reasonable for your project by using these numbers. If you cycle back over to the water tab, number 4 here, it tells you, for your project type, which we selected on the first page as education K-12, it tells us our water use intensity, and it repeats here so we don't have to flip back and forth how many people we said were in the building. To give you another piece of navigation, once you get into these different divisions, there's usually super helpful information if you scroll over. So on this, it tells you again, it repeats what it had on the reference, the water use intensity by the building type, so gallons per square foot per year. So you can start to populate either a low or a high number for your use type. And if you have a mixed use type, then it'll calculate that for you too, which is pretty cool. If you scroll over even more, it gives you another piece of helpful information. If it's a commercial use or residential use, it gives you typical flow rates. So you can link to WaterSense. So it kind of tells you, if you are a commercial building, if you're looking at a 0.8 as target for your toilets to flush, that's kind of out of the norm right now. So you may want to talk to the plumbing engineer. If it's out of the norm, make sure the pipes that they're designing, that they understand you're going beyond what's typical efficiency. So what I did to get the total water amount per year is I just plunked in like what I thought maybe I would expect for a school, not going anything too crazy, and it gives you the total annual water use, and I think it's down here. One of these I thought, oh, I know where it is. So much of this sheet is figuring out where stuff is. So on the program calc at the end, it gives you the water use intensity, and if you're using a benchmark, so that's useful. It wasn't here. I thought there was somewhere where I was looking around and I saw it was like a 38% reduction, which was, and it just automatically calculated that. It might have been on this results page. Yes, there's 36. So I didn't have to do any calculations. The sheet did it for me. That's awesome. Okay, I'm going to check the chat again. All right. Oh, okay. So right now this is a good question. How well does the spreadsheet work for single-family homes? And there is some really interesting information about single-family homes I noticed in this reference table. It's about EUI. Or it might be when we get to the energy screen. I'll touch on that. But I mean, you're putting toilets in a residential home, so you can look at that too. You would know the number of occupants and that sort of thing. So I think it is useful for all project types. All right, let's go back to the presentation. Okay, so we took a little dive into the water tabs and navigated around. So we now understand that there's something called water use intensity, and that's gallons per square foot per year. And you can also talk about a % reduction from a baseline. Energy. This is one of the more interconnected frameworks. So in this, we're going to talk about designing for energy, which is on the AIA framework website. It's about really designing a building as energy efficient as possible, and that can be through a strategy of passive or, going beyond building code, using renewables, and opportunities for continuous improvement. These are excellent questions to ask yourself during design, but then how do you really get into it? So if we're talking about energy, carbon, or lighting, so we're talking about the operational carbon of the building, the energy being used at the building site to operate all its lights and HVAC equipment, and then the lighting power density, like when would we want to look at those metrics? So early on, concept and schematic, we're going to want to try to set a numerical target for EUI. We'll get to what that means. Operational carbon and LPD, or lighting power density. And we want to share that and start early energy modeling if you can. And then design development and CDs, that's when you're really going to start iterating and verifying and tracking that you're getting to where you want to be. And also in the CA, you want to make sure you're getting what was specified. And if it wasn't, you want to be able to give feedback to your design team, like what actually was installed versus what was specified for the next project. And then if you've developed a metering strategy, which is always a good idea, because then you can get performance feedback rather than just what you think might happen based on modeling. After a year, you could get curious and really see how the building is actually performing. Was it used more or less than you anticipated in your occupancy schedules, et cetera. So once again, the AIA has come through with our cheat sheet, or if you can do only one or a few things right on their website. And we're going to be talking about this one, benchmarking and setting an energy use intensity, or EUI, and or lighting power density goal and working towards that goal. We're also going to touch on operational carbon. So first, we're going to talk about EUI. I'm going to go back out to the spreadsheet. So we'll go into the energy tab. Now, this one, I don't know about you guys, but I looked at this and I was like, oh my God, look at all this that you have to fill in. But then I realized, okay, you go over here and you're like, this is only if you have an energy model, and then you can populate here like what the energy model report is. And then, or if you have, it's an existing building and you have actual energy data, you can populate that here. So step 3, recording the monthly data, like that looked like an overwhelming amount of inputs, but it actually turned out to not be that useful for like setting these targets maybe. What's interesting is what I've highlighted here at the top. Automatically, it has created a site EUI, or that's what's being used at the building scale for the use type that you put on the first page. So we already know we want to be better than 75 because that was the average energy use intensity per square foot for all K-12 buildings like in 2003 when there was a big commercial building survey done. And it also gives you this, a benchmark operational carbon intensity. So based on that existing building database, there may have been a mix of natural gas and electricity or chillers and all sorts of different power sources. And it gives you kilograms of carbon dioxide equivalent per square foot per year. And then it gives you the totals over here, not by square foot, but the total per year. So I think that's pretty useful in itself. And then over here, hidden, again in the gray, is giving you some national averages and things. And a lot of this is also on the reference table page. So this reference table page, again, gives you really useful numbers for reference site EUI for all sorts of projects. And it does include, for the person that asked, single family homes, I think is on here. But it's not listed, even though it's in the database. And this is where I thought it had something interesting. Notes on program type, right here. single-family homes are benchmarked for annual energy and water consumption rather than per square foot. This is because all single-family homes serve the same functional purpose regardless of size. So I thought that was interesting that, like, for some project types or use types, they can vary a lot in size, and EUI isn't necessarily like the best metric to use for some project types to really get at lowering the energy. Like, maybe the benchmark instead of per square foot should be per person for single-family homes. And let's see, I think I want to, so I've showed you kind of how stuff automatically populates in there. And so we have talked, we now kind of understand what energy use intensity is, and that it's in kilo-BTUs or British thermal units per square foot per year. And I also wanted to show you this tool. It's, if you are a AIA 2030 signatory, this tool automatically populates the benchmark for your project, but you can also go to it separately and put in some basic information like your building name, the city and state postal code, anything with a red asterisk, and it'll give you the heating degree and cooling degree days, and you can, once you put in some program information, like whether it's a K through 12 school, or whether it's a multifamily, or whether it's a bowling alley, I think that one's one on there, it'll give you this cool little rainbow graphic that shows you what your baseline would be. So it's interesting, here it says 81, where in the tool it says 75. And then the target EUI would be 25 if you're trying to meet the 2030 commitment of 70% reduction. I think now it's 80%, but.
So if there is a discrepancy between the baseline, which one do you base on?
So I think in the 2030 commitment, it's using a different data set. It's using the Energy Star portfolio manager data set that's regionally based, in addition to the national CBEX database. The spreadsheet, one thing that the developers of the spreadsheet thought did is they said, we're just going to use the national average. We're not going to get into these regional nuances, because the spreadsheet was used for the Code Top 10 Awards, and they didn't want people playing around with the baseline. They were saying, you know, if you're this use type, this is going to be your baseline. And that way they would be able to compare across project types. Yeah. It does get a little confusing with the baseline, though. So are there any questions on how to calculate an EUI or a target, or how to get what this number is?
So you will populate the numbers you're targeting, and of course you have to work with your team and come out with what's needed, and the spreadsheet, because you have building calculations, and it will tell you where you are at and how far are you meeting the target.
That's a good question. So in the spreadsheet, and I'll show this more at the end too, okay. But there is a sheet in here that is the results. So on this sheet, it does, I'm going to make it a little bigger so us in the room can see it. If you have filled in something, it does give you kind of that percent reduction target, and it gives you kind of a color feedback. But there are multiple ways you could document what that EUI target is and give that back to your design team. We're going to keep going ahead with the rest of the metrics, and then I'll show you some ideas about how we can, possible ideas about how to communicate that information. This is just one way within the spreadsheet. It does give you some feedback. So, operational carbon. So there's a lot of information on operational carbon, and this stood out to me, that, you know, on the AIA Design Framework website, if you go into the energy design measure and you go into it, you can look into like best practices, and this will give you more definitions. There's like tons of information on there. But I was intrigued by how it says like a net zero carbon building is a challenging goal, but may be more accessible for some projects. And the project type, shape, size, and access to adequate renewable all factor heavily into a building's ability to meet this goal. So that gave me some space to think like, well, maybe it's not like every building, it's really difficult. Some buildings might be easier to get to net zero carbon. I thought, well, we better talk about what net zero carbon means. So net zero carbon means that you are trying to eliminate the downstream of the meter by designing an all-electric building. So as the grid, as our energy sources become cleaner, as our regional grid becomes 100% renewable power, what if you are using fossil fuel, natural gas to heat the water in your building? Then that building is not carbon-free. You're using a fossil fuel, non-renewable resource. So in order to set us up for success, as the grid is mandated to get cleaner, if we use all electric systems to as much as possible, then we are setting up the owners of those buildings and the operators for having a net zero carbon building. So we're not talking about the materials that the building is made out of. We're not talking about the circular anything. We're just talking about what is the building being powered by, what are the energy sources, and what is their profile. So net zero carbon is really just about what the building systems are. So we're going to dive in again back into the spreadsheet, and it's really in this reference table here. Move around stuff on the screen here. Okay. I made it 100% now. I can't see it. Okay. So it gives you the operational carbon intensity here per square foot per year. So for education K-12 school, that's where that 7.41 came from the first that was repopulated on the energy tab. So that gives us an idea for like 150,000 square foot building. I would multiply that by 7.41 to get the total operational carbon intensity per year. And these are all estimates. Let's see, there's some in the chat.
This is all from the same super spreadsheet.
Yep.
You can draw. Okay. Look into the reference and.
Yeah, the reference tables. It gives you a lot of good information.
Okay.
Yeah.
Thank you.
And I think the reference table is probably more useful when you're at the benchmarking and like trying to figure out what's reasonable stage. So if you're looking at a K-12 school and you're like, okay, 7.41 is the baseline. What if I did 50%? Like, is it possible to reduce by 50%? And like, how would you get there? Then you would need to go back to the let's chat. You can, oh, that's water one. Okay. It's easy to get lost in the spreadsheet. You can go back to these carbon emission factors, and if you, and these are national, if you wanted to get more nuanced, you could look at the New England ISO grid, but you could start with national and say, okay, national, and say, okay, it's a 100% electric building. This is the emission, and you could look at that there. And it has a little area you can document your energy model if you're doing that. All right. So the question that came up is, can you specify at all how much more impactful it is to minimize energy use within the building versus using clean power? Does this apply to smaller buildings? Is there a rule of thumb as to how much carbon you can save for one or the other? So that becomes a little more complicated in that there are, and we're going to get into this in a few minutes, but there is carbon being emitted in the manufacturing and the transportation and the installation and the disposal of all the materials you're using for the building. So building, the building shape, its size, and its use all impact its operational carbon and also its embodied carbon. So there isn't necessarily a general rule of thumb other than the only one I can think of is like if you're designing the building the most efficiently for its program and it's, what it's being used for, and you're designing the envelope and how it's masked in the windows and all of that, you're also designing for cost. There's so many factors. So I think that's a little bit beyond where I'm heading with these. I'm really trying to get back to the basics on like, okay, let's find a number that you can really like hang your hat on and then check against, because you can easily get into the weeds and try to find rules of thumb for things that get to be really complex, if that makes sense.
To me, this question also brings up the issue of resilience. So regardless of the type of power, the least load is going to give you the most resilient design. Right.
And there's always going to be that, like Hummer that runs on hydrogen fuel cells example of a building. Like not practical, but using some technological solution to get them over the sustainability or like efficiency finish line. There are always going to be projects like that. But what I wanted to focus on today is really just like, where do you find the basic metric information, and then how can you benchmark, and then, establish those goals early so you can check your work against them as you're getting into the weeds. So I think that's where a lot of us can start to struggle, as you get really complex really quick. So, okay, we're about halfway through. We've talked about operational carbon intensity, and we understand that that's in kilograms of carbon dioxide equivalent, so that includes other greenhouse gases per square foot per year, and you can set that target as a % reduction or a number. Okay, the last of the energy, lighting. So just to refresh everyone's memory, when we looked at this a little bit a little while back, it says benchmark and set an EUI or a lighting power density goal and work towards that goal during the design process. So we're going to dive into what lighting power density means. So I can show you again instead of toggling back out to the spreadsheet, it's really that same reference table. It gives you on the reference sheet, it gives you the lighting power density based on different use types. And this is the benchmark, the 2003 that you want to be better than. And then there's also, there's this website here that the AIA recommends on the tool. It's linked in the spreadsheet. But it gives you basically the IECC 2021, which is our upcoming code, minimum lighting power density for different program types as well. So you can take a look at what code is going to be. You can take a look at what the 2003 national data set is, and you can come in somewhere in between. Lighting power density is one of those strange metrics, like it's all of the lights, all of the wattage for lighting divided by square foot, either by building or space by space. So it's a little strange because it's not often that all of the lights are on all of the time. It's really, you know, a capacity thing, like how many lights, if the lights were on all the time, what would that density be? So lighting power density, to remind you, it's total watts per square foot, and we can also use, you know, set a % reduction for that. Okay, now we get to the hot topic that everyone's talking about, embodied carbon. This is in the design for resources area in the framework, and it's really in the wheelhouse of a lot of architects. Like we are already dealing with materials. So how can you get started? How can you, when can you integrate looking at embodied carbon into your workflow? In concept and schematic design, you could set a numerical target for reduction, either by material, or you can look at your overall building. You can say, I'm gonna look at drywall, it's an interior renovation project, and I wanna reduce the embodied carbon of my drywall by 20% from the baseline. Or I can say, for a K-12 school, I wanna reduce by the typical building. This also, like energy modeling, does require some modeling, but I'm going to show you really more at the front end of it, like, and where to find this kind of information so you can use it early in design, rather than jumping in and trying to do a tally model right away, or another whole building life cycle assessment type of model. And the CA phase is also super important, having a partner that's willing to give you the information that you need. So once again, the AIA, if you can only do one or a few things, embodied carbon, minimize embodied carbon related to high impact materials such as wood, concrete, and steel, minimize the extent of aluminum, and not use XPS or spray foam insulation. For tenant improvement projects, focus on carpet, gypsum board, and FF&E, and consider product lifespan, reuse, and take back. That's a lot of information in that one sentence, but that really gives you the high level stuff of what you need to be thinking about. And again, embodied carbon, we can talk about the individual materials or the whole building. And there are various tools where you can start estimating for the whole building scale. There are also some for the material scale. What I have on the screen here is a Sasaki designed web tool called Carbon Conscious. It's available by following the link and signing up. And it's a sketch-based tool where you can kind of draw a building and say this is going to be a steel building with brick, and it'll give you this many stories, and it'll give you a rough order of magnitude of what your embodied carbon will be. So you don't need to go into tally, you don't need to do a whole bunch of extra gymnastics. It'll give you a basic understanding for a lot of different building types what your embodied carbon footprint might be. What's cool about it is it also does the same for landscape. So if you're an extensive landscape, it'll use that as it'll calculate that as well in site work. EC3, a lot of people might have heard about. It's becoming more and more powerful every day. It's also a web-based application available for free if you sign up. And you can look at either materials individually, or you can look at some whole building models. So what I'm showing you on the screen, when you launch in, you can either go to the find and compare materials, or you can plan and compare buildings. And if you have a Revit model, that, you know, the structure is in there, and, or you have a narrative estimate of the structure, the tonnage of steel, you can start building a building in there and just kind of compare different scenarios. So I've used that to compare like CLT versus steel, you know, just big rough order of magnitude estimates. So there's a lot of ways you can use this to make early decisions or even set benchmarks for either materials or buildings. Payette also has a very helpful kaleidoscope tool if you're just wanting to look at facades. I think they've built this out also with floors and ceiling systems now. So what it gives you is based on which facade systems you've checked, it gives you an order of magnitude of its kilograms of carbon dioxide equivalent per square foot. So you can see here on the bottom rain screen, a wood rain screen is the clear winner, but you know, it's surprising, like EFIS with mineral wool isn't doing too bad either. So if you're comparing different systems, this is a good order of magnitude. Obviously, if your assembly is slightly different from what's in here, it's going to have a different footprint, but it can start telling the story of like how significant, you know, insulated metal panel is in relation to a formed metal panel, for instance. It's also super useful once you get into the specification stage of your project and you want to set a reasonable target. The Carbon Leadership Forum has last year republished their baselines. It's version 2. It's available at their website as in a report form, and it lists by material type, typical, baseline, and achievable. And these are average values based on, you know, all sorts of data sources that it lists over to the right. So if you want to say, you know, the performance in the embodied carbon has to meet for, you know, your 4,000 PSI concrete 406, you can, per meter squared, you can put that in your specs and see if you can get it. At least ask for an EPD, Environmental Product Declaration. Okay, so we've jumped through a lot of things. We've talked about water use intensity, energy use intensity, operational carbon intensity, lighting power density, and embodied carbon either by material or whole building, and that is in kilograms per carbon dioxide equivalent per material unit, which can vary, or by square foot if you're talking about a building. Now, how do you integrate this stuff into your workflow? I'm going to end with showing you all some ideas about how to just put these 5 numbers into your projects. So, and I don't think any of these are local firms, but MSR Design has put out there publicly available how they put this metric data right in their Revit sheets. So they have a sustainability metrics G sheet, and they populate this information there, and it's always in the Revit model, and it's published and printed along with the rest of their set. So there's a way to, you know, track it over time. So that's one way you can start tracking this if you're early into Revit or you're producing a lot of work. Integration into the Revit workflow might be a really good way to make sure that the metrics are front and center from the start. Another thing you can do is you can, you know, create either your own checklist for projects where it's tracked, or you can use the super spreadsheet, but you don't want it to live necessarily just in the spreadsheet. So it's important, if you have a project checklist, that somehow that is visualized. This is an example over here from Sarah Architects out of the West Coast. They're in Portland, Oregon, I think. But they have a, you know, pretty complicated project compass, and it's generated for every project. So it doesn't have to be this complicated. It could just be a card with like 5 boxes, but somehow that information needs to be in front of people as they're working on their projects, whether it's posted up or it's on the project start page or however you're working. It's important to have the metrics looking nice and in front of everybody. The other thing to make sure you're doing as you're incorporating these metrics, trying to get it across your project, is tell everybody what they are. Make sure that there's at least an annual firm report for your whole portfolio. What we're seeing on the screen here are 2 pages from BNIM's annual report that they have published online at the bottom. And they have a couple ways of looking at different things. So they have energy, they have firm-wide metrics like the average for everything up here on the right, but they also have the data for each individual project. It's kind of like each project has their own lane and who's winning in their lane kind of image. So I think there does need to be a combination of, you need some sort of feedback loop established, and it's important for it to look nice or else people won't really care. I'm going to share these slides with you, so there's all these links to things we've looked at together here. And I'll open the floor to questions. We have another 10 minutes. Maybe there's something I didn't go into it enough depth on and you'd like to see more.
This is great. We have tremendous information to filter through, and it's wonderful that you list the resources here. So later on, if we have more questions and we want to learn more about the particular tools, we can just click into it. Again, that this Allison says we could record the meeting. So later on, if we have questions, we can always click into the recording and look up the resources as you work on your project. It will be helpful. And I also just want to quickly mention, I think I saw Peter Papesh, our founding chair. He finally signed up. It's a little bit hard for him to get him to sign up. Just want to say hi quickly and acknowledge that he's here joining us today.
Oh, I can stop sharing, I guess, and go back. If anyone wants to come on camera and just say hi, that's cool. Or we can.
Okay.
I'll be happy to go into anything in more detail.
Okay.
Are there any questions in the room?
I do have one question about so operational things. Is this more focused on the design aspect, or are there operational aspects to the building that could be plugged in terms of how a building is set and just or measured, and also I think it looked like there's some provisions to take to like check back like in a year. Is that right?
Right. So I think for a lot of these, if you're doing like an interior renovation and it's in a larger building, or you're taking an existing building and you're trying to figure out, well, how do I make it better? I still think there is use in the code super spreadsheet, because they're on the energy tab. Share again. Sorry. I'm just going to share the energy tab again. So here, the measured values, like in order to understand what your EUI currently is, if it's worth doing any interventions to the energy systems, and you have electricity bills, gas bills, you have understanding of how much, if there is a district chilled water or steam or on-site generation, you can fill these numbers in, and it will it'll generate your carbon typical operational carbon for you. So that's a useful number to know, when you're talking about, you know, what the building is offsetting, or, you know, what are the opportunities. So there's more on the spreadsheet than I've gone through. I mean, we didn't even look at some of the other ones. But I think if you're gonna start with anything, the reference tables are super helpful. And then, you know, this last sheet that has the program calc. I mean, I think if you're gonna start anywhere, the energy and water tabs are the most easily, like, quantifiable to get started. And especially if you're not already tracking these things well across your practice, like starting there and seeing how well you can do. Because as we all know, like, we have a limited amount of time between 2030 to get to zero carbon is where we want to be. So anything that has an impact on carbon is going to have a broader impact on and have ripple effects on the other categories. But that isn't to say, like, don't care about, you know, providing good indoor air quality or any of those other things at the expense of energy. But you know, if you're able to start tracking this stuff and how to get there, you're going to naturally have to balance those things, because the client is going to be asking those other questions. They're not necessarily always going to be asking, like, what is my EUI and how much carbon are we emitting and those kinds of things.
I think you also have to deal with the project type. If you're working in the residential or institutions, and also if it's new construction or existing renovations, because with new construction, you might have more freedoms and more options that you can integrate early on. But with existing construction, you already have a building envelope there, and it makes it difficult sometimes because it eliminates some of your options that's available. And I'm just curious about one thing though, because it's really great if we can have a client that's signed on board with the approach, but it's how I personally don't know how it goes on that first initiation, that how difficult it is to have a supporting client in this run from the very beginning.
Right. I mean, I think the business case for sustainability is pretty well established, but that word sustainability equates money to a lot of people. They see dollar signs. So I wouldn't necessarily call these metrics sustainability metrics. They are performance metrics, right? We want to give the information to all of our clients how their buildings are performing. And so you start off with the information like, okay, if you're designing an institutional building or a retail showroom, those are going to have different baselines. They're going to have different expectations for lighting power density. They're going to have different water use. And just presenting the information like, okay, this is what a typical building uses, and let's try to be better than that in performance. That's going to save the client money in operations, right?
And they will, in that way, they will be more acceptable when open to the discussion or the approach.
Right.
Okay.
Right. So this is really the entry point of the overarching topic of sustainability and resiliency, but it really is, this is just really like how well is your design performing, or where are there opportunities for using less resources.
Thank you. We have 2 more minutes. and then we'll be around, the clock.
We can give people 2 minutes of time back for their 1 o'clock meeting.
Yes, we could do that too. Well, thank you. Jeff, you have any questions?
Well, you commented about the lighting metric, that it's not necessarily a metric of use. So it seems to me to be a metric of demand. And so I'm wondering, is there a similar distinction among other metrics? Like we're talking typically about use.
Right, but all of these that we mentioned today were predicted, or they're like modeled values. So they also are pretty low resolution. So if you look at an EUI of a building, for example, and you expect it to perform to that EUI every day of the year, it's probably not. It's going to have some days that are going to be more intense and some days that are less intense, and some days where no energy is being used at all. But when we're looking at a low resolution, having that granularity isn't necessarily helpful when we're trying to set overall project targets and track them against. But it is important to keep that in mind, because it is very easy to kind of get lost in the EUI as like, okay, that is absolutely what it is. It's really it's a bit of a mathematical like generalization. They're all kind of dumb metrics that are only useful if they're looked at in comparison to one another. If that makes sense.
They're useful as relative metrics.
Yes.
Rather than absolutes.
Yeah. All right, should I end? Yeah. Thank you, everyone.
Thank you.
Thank you, Allison. This is great. I think we have a very good meeting. And thank you everyone for attending. Please feel free to sign up again for our next meeting after the summer. Thank you.
Thank you. Bye.
Okay, bye.